as you can see, I've upgraded a little bit. I went ahead and ordered myself a bigger chalkboard so I could do more than one tiny problem at a time. I hope this works out for you guys, and me. All right, so these two examples follow the idea of how we learn how to write a sequence function given a sequence. So the first example, we have this sequence of numbers 10, 14, 18, 22. If we remember, the general form for any sequence a sub n is it's based off of the first term plus the constant difference times n minus 1. So what we just need to do is substitute in the first term and the constant difference. That's it. If we have that information, we can write the sequence. We can clearly see our first term in this one, a sub 1, our first term is 10. And looking for the constant difference, you can probably see that what's going on to get from one term to the next is that we are adding 4 each time. If you don't see it, take any term and subtract the term before it. 18 minus 14, that gets you your constant difference of 4. 4 is d. So we have the value we're going to substitute here. We have the value we're going to substitute here. We just write the function. A sub n, any term in the sequence, is 10 plus 4 times n minus 1. And there you have it. If you want to check your answer, it's really not that difficult to do. All we have to do is pick some number in the sequence. Like, for instance, we could pick this term. And as long as you know what n is, n happens to be 4 because that's the 1, 2, 3, 4th term. Let n be 4, put 4 in here. 4 minus 1 is 3. 3 times 4 is 12. 12 plus 10, 22. Checks. I buy it. I just randomly checked the 4th term and it worked. So there's your formula. These can also be given using function notation. I haven't mentioned this yet, but I did show you that a sub n is just another way to write a function. So if you wanted to write this using f of x, you could write it as 10 plus 4 times, instead of your input being n, now our input is x, so we're going to write x minus 1. That's another way you could give the sequence. I typically write them using a sub n. That's what you'll see in most textbooks, but you will see some authors write f of x notation. So our next problem, we have this sequence right here. We're just utilizing this general formula again because we see that it's arithmetic, because there's a constant difference as you go from one term to the next. You can see that d is 2. Is d 2? If d was 2, that would mean we add 2 each time. If we take 28 plus 2, we get 30, not 26. So it's not 2. We're subtracting 2, so d is negative 2. Again, if you take any term and subtract the previous term, 22 minus its previous term, 24, that'll get you a result of negative 2. That's how you can determine that. And now we know our first term, we know our difference, our constant difference. We just put it into this formula. A sub n is our first term, 28, plus our difference, which is plus negative 2, times n minus 1. Some of you are probably thinking, do we have to write plus negative 2? The answer is no. You can write that using subtraction. You could easily write a sub n is 28 minus 2 times n minus 1. I, in fact, typically find that I'll write minus 2 when I'm subtracting to get from one term to the next, as opposed to writing plus negative 2. And whenever we get into geometric sequences, I'll explain why.